So the two sets can be combined in many different ways to form a new set. So we call it set operations. So based on this definition 11, make sure you know the meaning of union set, intersection set, difference set, complement set, and disjoint. For union, we can use this symbol A union B. So A union B is the set for all elements that exist either in A or B. For intersection, we use this symbol A intersect B, meaning that this area stands for all the elements that exist in both A and B. And then the difference A and B, which is A minus B, stands for the element within this area. And then for A prime, which is the complement of A, stands for all elements outside of set A. And then lastly, for disjoint, we use A intersect B equals to empty set. So meaning that the two sets does not intersect, and there is an empty set in the intersection. Now let us see the example 12. Let the universal set be A, B, C, D, E, F, G, H, I, J, K. And for set A, we have A, B, C, D, E. For set B, we have C, D, E, F, G, H. And for set C, we have H, I, J, K. If you want to find the set A union B, that means you combine all elements in set A with all elements in set B. But notice that for both set A and B contain C, D, and E. So you can consider them as one element. For example, C in A, C in B, you consider as 1C in your union set of A and B. The next one is set A intersect B. For this case, you need to compare between set A and set B and find out what are the elements that exist in both sets. So for this side and that side, we have C, D, and E. So the set A intersect B will be C, D, and E. And for A intersect C, we have empty set because there is no identical elements in both sets A and C. To find the difference between set A and B, you need to do like this. First, you need to find out what are the identical elements that exist in both sets. And then you have A, B, C, D, E, and here only C, D, E. Then you minus A, B, C, D, E with C, D, E, then you will remain with A and B. And then for A prime, which is the complement of set A, you just need to list down all the elements that exist in universal but does not exist in set A. Definition 11 says A1, A2, A3 are mutually disjoint if and only if no two sets AI and AJ have any element in common. So these definitions apply for more than two sets. So whenever no any two sets have any element in common, that means you can write like this. For all I and j equals to 1, 2, 3 until the end, you have AI intersect AJ equals to empty sets. Now let us see example 13 on how definition 11 works. So let A1 equals to 3, 5, A2 equals to 1, 4, 6, and A3 equals to 2. So all these three sets are mutually disjoint because all the intersection give empty set or null set. But for example 13b, let B1 equals 2, 4, 6, B2 3, 7, B3 4, 5. We have the solution, which is B1, B2, B3 are not mutually disjoint, because if you notice, for set B1 and set B3 have the common element, which is number 4. So generalized unions and intersections. This one applies for more than two sets as well. So if you want to write down the union of the sets A1, A2, A3 until AN, you can use this symbol. So AN equals to union power of n subscript I equals to 1 AI. Also, for intersection of the sets A1, A2, A3 until AN, you can use this notation. So if you limit the sets until 3 sets, that means you can refer to this figure. So this is the figure for set A union set B union set C. So just ignore the XYZ. Basically, this figure shows the union of 3 sets, and this is for the intersection of the 3 sets. So we just shaded the area in the middle. Now I show you the list of basic laws on how the set operations work. So you need to remember and memorize all the laws with their identities. All these laws with their identities are important for you to prove in any problem in set theory. So one of the illustration that I can give is based on the De Morgan's law. So the De Morgan's law states that the complement of x union y equals to complement of x intersect with complement of y. So how it works based on the Venn diagram? Let me show you. So by looking at this figure is for x union y, and then if you put a complement symbol which is x union y prime, that means you consider this area. So similarly, if you consider the complement of x, which is all this area, and the complement of y of all this area, and you find the intersection for both complement sets x and y, you get this one. So because of the Venn diagram for complement x intersect complement y similar to complement of x union y, by De Morgan's law you can state that this one equals to this one. So the idea behind this illustration is whenever you forget the laws, you can use Venn diagram to recall it. So you can draw the circle x and y with the rectangle to find out the similarity in terms of the notation. Ordered pair. Let x and y are sets. If smaller x element of set x and smaller y element of set y, then an ordered pair is written as xy. And xy is not necessarily equal to yx because the order is important. The Cartesian product of two sets x and y can be written as x product y equals to bracket xy such that x element of set x and y element of set y. For any set x, Cartesian product with another null set or empty set will give empty set. For example 14, let x equals to AB and y equals to CD. Cartesian product for x and y equals to AC, AD, BC, and BD. Basically all the possible ordered pair based on the set x and set y. Similarly, for Cartesian product y and x equals to CA, DA, CB, and DB. Computer representation of sets. Sets can also be represented by using computer, which is using bit strings. A bit string is a sequence of zeros and ones. Example 1011, 1011. This bit string also can be known as binary numbers. The length of a bit string is the number of digits in the string, meaning that the length of 1001, 1101 equals to 8. That means there are 8 digits in these strings. Also, elements appear in order in the bit string. 0 stands for the element is absent and 1 stands for the element is present. So let us see the next example. In this example, let universal set equals to 1, 2, 3 until 12, and then set A equals to 2, 4, 6, 8, 11, 12, and set B 1, 2, 5, 7, 8, 10. So now, determine the bit string, string A union B, string A intersect B, and string A complement. So the solution for this example is, since the set U has 12 elements, then we use a bit string with length 12 to represent the subset of U. So string A equals to 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1. And for string B, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0. So meaning that for each binary number here, so this is stand for the first element, this for the second element, third element, fourth element, and so forth. So for string A, let us see this set A. So they're starting with 2, 4, 6, 8, 11, 12. So all these digits for this set A elements basically stand for 1. So other than that, 0. So for digit 1 is not here, so 0. So we're starting with 1, 0, 1, and so on. So similarly, for set B, we have 1, 2, 5, 7, 8, and 10. To create the string B, so we have 1, 1, 0, 0. So 1 and 1 over here stand for the presence of digit 1 and 2, and there's no 3 and 4, that's why we write down 0, 0. And continue with 5, which is give 1 here, and there's no 6 here in set B, then we give 0 here. To find string A union B, you need to make sure that either of the two bits is 1, then the corresponding bit of string A union B give 1. So let us see this illustration for string A union B. So this row represents the string A, and this row represents the string B. So for A union B, if one of these two bits give 1, that means the result is 1. Similarly to if 1 and 1 also give 1. However, if both bits give 0, then the result becomes 0. Okay, how about the next one? String A intersect B. For string A intersect B, make sure both the corresponding bits are 1, then the result is 1. So this row represents string A and this row represents string B. To find the string A intersect B, make sure the two bits are 1 so that the result is 1. So for this column, 0, 1 get 0, 1, 1, then you get 1, 0, 0, 0, 1, 0, 0. And lastly, to find the string for complement of A, basically the reversal of the binary number. So for string A, we have 0, 1, 0, 1, and so on. But for string complement of A is the reversal, such that 0 becomes 1 and 1 becomes 0. So if you still don't get it, you can try to do the tutorial question as follows. So this example, make sure you understand so that you can go for a harder problem. So that's all for this video.